Okay, so in this video we're finally going to learn about Newton's laws of motion. So there's Newton's first law, there's Newton's second law, and then there's Newton's third law. So three laws of motion. Okay, so I'm going to go back to the first one. We're going to start there. First law of motion tells you an object is at rest. Okay, an object at rest, and an object just resting like this, will stay at rest, stays at rest, and an object in motion stays in motion unless acted on by an unbalanced force. Yani, if there's an object just sitting there on the floor, it would never move. It will stay at rest, okay? If nothing acts on it to move it, it will stay at rest. An object in motion, an object moving, will always keep moving unless something acts on it. Now here on Earth, objects don't keep moving because there's always gravity acting on this object and pulling it down, making it stop. If you kick a ball in space, the ball will keep moving because there's no gravity unless the gravitational force of a planet pulls it in, or it hits an asteroid or a comet, but it will keep moving unless an unbalanced force acts on it. So this is the Newton's first law. An object at rest will stay at rest, like this. An object in motion will stay in motion, like this, unless an unbalanced force acts on it to make it either start moving or to make it stop moving. Okay, so this is Newton's first law. Newton's first law and inertia. So what's inertia? Inertia is the tendency of an object to resist any change in motion. Because of inertia, an object at rest will remain at rest unless a force makes it move. So basically, the law of inertia is the same as Newton's first law. Newton's first law is also called law of inertia. Okay, it's the same concept. An object at rest will stay at rest. An object in motion will stay in motion. Same concept. Okay. See, Newton's first law of motion is sometimes called law of inertia. Mass and inertia. There's something you need to know about inertia and mass. Objects with greater mass have more inertia, and it takes more force to change their motion. Look at this. It's very simple here. Look at this is a 300 kilogram ball, and it's harder for this man to push this ball and move it, change its make it to get it in motion. It's harder for him to push a 300 kilogram ball than a 30 kilogram ball. Okay, why? Because it has greater mass. Mass yani how heavy it is. Okay, so this has a mass of 300 kilograms, this has a mass of 30. It's easier to move this than to move this. This is because greater mass, more inertia. That means you need to have more force in order to change the motion of an object that has more mass. An object with a larger mass, see, has more inertia. Changing the motion of an object with a large mass is harder than changing the motion of an object with a smaller mass. Which would you rather change the motion of, a car or a ball? A rolling ball would be much easier to change the motion of than a car. A car needs an engine to move. You can't actually just push it with your hand. It's really difficult to move a car if you're not actually driving it. If you're trying to push it with your hand, but it's very easy to move a soccer ball because this is really light and this is very heavy. Friction also has to do with Newton's first law. The unbalanced force that causes an object to stop is called friction. Okay, friction is a force that causes an object to stop. So remember, friction is a force that opposes motion. Okay, if there's less friction, you'll be slipping, like you're able to slip on ice because there's less friction. More friction would actually stop you. If you're trying to roll down a mountain and there's a lot of friction, you would be able to stop in the middle. That's about Newton's first law. Newton's second law tells you that the acceleration of an object depends on the mass of the object and the amount of force applied. Okay, acceleration, yani if an object speeds up, slows down, or changes direction, depends on the mass, okay, of an object and the force applied. Mass and force. So to get a wagon to accelerate, you have to pull. You have to put force in order to get this to move. If the mass of the wagon increases, you have to put more force. That's all you gotta know. Like if you have something that is heavier, you need to apply force to move it. And if it's heavier, you need to apply more force. That's all. This sounds a bit confusing, but when you see examples, that's it. That's all you gotta know. If it's heavy, you gotta apply more force. So it's basically just common sense. Okay? So if something has a small mass, it has large acceleration. That means it can move really fast. If it has a large mass, it has small acceleration. Okay, you don't have to know this. We're not going to take this equation here in this lesson. But that's basically Newton's second law. So if same mass, here they have like the same mass of this. This is the same mass here and here. If he applies more force, it will be able to accelerate more. Okay, this one, different mass. This is lighter than this. See, this is heavier. It's different mass, but if the same force is applied, he applies this, same force here, same force here, this would speed faster. Look, speed increases slower. You see what happens? Because he's applying the same force here and here, but this is heavier. So this is basically Newton's second law. It has to do with mass and force applied. So here, if it's the same mass but different force applied, this would be speeding more. Here, same force but different mass, this one would be speeding more. You would know all of these in common sense. It's pretty easy once you apply common sense to those. Third law, I don't know if you've heard of it, but third law is basically the easiest one because it's kind of known. I don't know if you've heard of it. Third law tells you is for every action, there is an opposite and an equal reaction. Like for example, he jumps on the trampoline like this, there's an equal reaction up there. Pushes on the ball like this, the ball pushes an equal reaction like here. The ball hits like this, the ball hits back like this, equal reaction. For every action, there's an opposite and equal reaction. Tire pushes on the road, road pushes on the tire. Rocket pushes on gas, gas pushes on the rocket. Man pulls the spring, spring pulls on man. Earth pulls on ball, balls pulls on earth. There's always an opposite and equal reaction. Look, to every action, there's an opposite and equal reaction. That's Newton's first law. That's all you have to know. How you'd be tested on these? I'd basically be giving you a scenario, and I'd be telling you which law of motion is it. Is it first law, second law, or third law? And you'd have to know according to these laws. You'd have to know these laws so you'd be able to identify the situation in any assessment that I give you.